Hello everyone and welcome to the latest SMTA webinar. So today's topic is going to be all about the upcoming MASTA 9 release. Hopefully everyone can hear okay and see the screen that we're sharing. So I am Tom Harvey. I'm the technical lead in the software department. So I've been working at SMT for the past 9 years, working mainly on the MASTA software, also assisting on engineering projects. So I'm going to introduce the new MASTA 9 release today. In terms of when this is going to come out, we expect this is going to be very soon now, so hopefully within the next week you'll be able to get your hands on it. But if anyone would like an early release version, then you're welcome to get in contact and we can send that straight to you. This is the last of our webinars this year, but please watch out because there'll be plenty more coming in the next year, as well as additional training sessions and all sorts of other things going on. So I'm not going to cover everything that's in the MASTA 9 release today. There's many kind of small features that we're not going to have time to go through, but please have a look at the release notes, and if you've got any questions on any of the new features or any comments or suggestions for things you'd like to see in the future, then please get in contact via the normal methods. So for example, the support email, and we will get back to you. So the things I'm going to go through today is, first of all, kind of on our main features in the MASTA 9 release is some improvements to MBH mode. So this includes a new interface, some new results in terms of sound power output, and also exporting to acoustic packages. So I'm going to first of all go through that in kind of some detail and show you the new features on that. After that, I'm going to go through the new shaft meshing feature in MASTA, which lets you create FE meshes of your existing MASTA shaft geometry or within the interface. I'm then going to talk about some new spline modeling technique we've added into MASTA 9. So this is to allow you to create more flexible spline contacts. I'm then going to talk about some new bearing mounting options we've added, and then finally, the final feature I'm going to touch on is the new CVT model, which includes the forces from the sheaves. And then finally, after all that, going to go back and just tell you about a few of the things we're working on in the future. So what you can expect to see in terms of MASTA in the next year. So you should be able to ask questions any time during the webinar, and they'll pop up on my screen, and I'll try and answer your questions as I go, or come back to it in the end. But if we don't have time for answering all the questions, then we'll try and get in touch afterwards and make sure everyone gets their questions answered. So yeah, most of this demo I'm going to do within MASTA software. So I'm going to be showing it the features live in MASTA. Yeah, if you miss anything or want to know how anything works again, then yeah, again, please ask us. So this is MASTA 9, which you should be able to see on your screens now. So there's a number of changes to the interface in MASTA 9 that you'll kind of notice as you use it. We're continually trying to update the look and feel of MASTA to keep it looking as a kind of modern software. So you'll see some slight changes to the formatting of things like the tree view on the left-hand side here, and this is all to make MASTA work better on modern computers with sort of high-resolution monitors, which a lot more of our customers are using these days. So you should see improvements there. So this is the model I'm going to be using for the first part of this demo. It's probably a model that a lot of you are familiar with from various training sessions that you've had from S&T employees over the years. And the first thing we'll look at, as I mentioned, is the MVH improvements in MASTA 9. So if we start with the inputs into our gear wine analysis, the first change is that a lot of the setups are now done on a nice editor page, which you can find by clicking on the top level of the assembly view, tree view, and then selecting the editor tab. And this is a kind of report we've set up for you. So on the left here, you'll see things like your number of modes you want to solve for, and what excitations you want to use for your various gear sets. And if you had them in this design, you'd also see electric motors, point loads, etc., all listed on the left here. And on the right are other options which don't really affect the actual analysis, but they will affect the processing of the results. So these are things like the damping, how many harmonics you want to include, and the kind of speed and frequency ranges. Also, if you've got a design state or duty cycle, we do have reports on there as well. So this is more convenient if you want to change the setup for multiple load cases in one go. So for example, if you wanted to change all your planetary gear sets to advanced LTCA, then you can select all the inputs there and press the first letter of that option, and it will cycle through all the A's, for example. So this makes it very quick to set up multiple load cases if you want to do that. So I'm going to switch to this load case here, which I've just run. So one of the major interface changes is found in the dynamic response tab. So for example, if we first look at the casing, so you'll see previously we had some options at the top here, some down the bottom. We've kind of consolidated that into a single set of options, all found below the chart. But at the same time, we also added a lot of additional functionality. So we've got a number of tabs down the bottom here, and these are results that affect several of these charts that we see for the results. So on this first one, we got general settings such as your frequency and speed ranges. We do also have hidden here a number of additional frequency options as well. So we've added a lot more functionality for deciding at what frequency points you can see your solution at, and yeah, this is something that a lot of our users ask for, just a bit more control over what is shown. And in previous version of MASTA, we'd also remove a lot of the points that don't really affect the shape of the graph so much, but there's now an option to not do that if you wish. It doesn't really change much on the plot, but it will mean that your data output will be exactly as you've specified. On the next tab, we have listed the excitation sources that we've got in our load case. So this is grouped by, say, gear set or an electric motor input. So we can easily kind of turn off a particular gear set, and we can quickly turn on a certain mesh of that gear set, for example. So this is a lot more flexible than the previous version, where you could either look at everything or a single gear mesh excitation. You can now use these checkboxes to look at anything you like, really. The result options tab controls which particular results you're looking at. So kind of similar to before, you had a drop down here with various different results such as displacement, velocity, acceleration, your energies and forces. I'll come back to some of the new results in a minute. So acceleration, for example, we can now Previously, you'd only have magnitude option here. We now have options for phase, or the real part, or the imaginary part. You can pick the local or the global coordinate system, and whether you're looking at translation or rotation degrees of freedom. We also give you more options now for which degrees of freedom are shown. So you can look at multiple directions at once. So for example, you can look at X, Y, Z components and it will plot them all on the chart. We also have listed here all the nodes for the current component. So because I'm on the casing FE at the moment, we've got a lot of nodes listed. If you want to, you can look at multiple nodes at the same time. So you can select the checkboxes next to all your accelerometer locations, for example, or all your bearings, and they will all be shown on the chart at once. If there's something you particularly want to look at a lot, so for example, I wanted to look at these two bearings, for example, then we do have an option now to be able to create groups of nodes that are then saved with your master file. So on this drop down here, I select change between current items, so in this case it's the casing, and switch to the groups option. I can pick which group I'm looking at or add additional groups, and then I can start to add particular nodes into this group. So I can create a group with all these bearing nodes in it, and that will appear on this groups tab here. And these groups are saved with the design, and they're also saved so that you can get to them from different load cases. So if I now run a different load case, we'll see we can now get that same group of options appearing there as well. So yeah, I can switch between my load cases and I'm still looking at the same group of nodes. Another feature which actually is now available in all of MASTA, not just in the MVH mode, is on all line charts now. So for example here, we've put a lot of results on our chart, which is not very useful, but we can now pick out the particular lines of interest. So this one and this one, say, you can select those lines and it'll highlight those and just make a legend of just those particular lines we've picked out. So we can plot a lot of results at once, pick out the particular ones of interest, and then export that data. So when we select our copy data clipboard option, we have now the option to just export the selected lines that we've picked out as being of interest. So that's, and then to clear it, we just need to click on the graph and we'll go back to showing everything again. So once we've kind of looked at some responses, we also have some new features in the 3D view available as well in our MVH analysis. So if we switch to our 3D view, so previously you had a few options to look at either the coupled mode shapes or the uncoupled mode shapes. They are still available, but that selection is now done in the 3D view here, and we can pick which mode shape you want to look at, for example. But we also have these additional results of the operating deflection shapes. So these let you look at the actual results of that MVH simulation. So I just had a quick question pop up here. So to look at multiple results, Do you have to use control and select? So you don't. You just, all you have to do is just check the checkboxes here. So whatever you've got selected in terms of these checkboxes will be what is shown in the plot. So you don't have to press any keys, just check the box, like so. So yeah, so if we're looking at the operating deflection shapes, so this is actually this can be a combination of several different mode shapes. If you've got a particular resonance where more than one mode is excited, then the shape, the deformation of your system can be quite different to what that single mode is showing. So we can select which order we're looking at, or you can also do it by excitation. So looking at a particular gear mesh, for example, or electric motor excitation. So we can look at that. We can enter what particular speed we want to look at, or as a frequency. And we can then animate that deformation as well. So this is now animating the actual dynamic response of the full system at this particular speed. So we can use this to see which particular areas might be radiating noise, for example. So I'm currently looking at the normal velocity of my FE components as the contour in the 3D view. So this highlights areas that are likely to be causing most of the noise from a particular component. So previously you were limited to kind of just looking at this at a particular accelerometer location which you've predefined, but we now have the option to kind of look at how any part of our FE component is moving at a particular speed. The other thing you'll notice in this master release is the controls for all the 3D views have been updated. We tried to kind of modernize the kind of look and feel of them. So you'll see various options down here for turning off on sort of solid shafts and components. A lot of these settings are exactly the same as you saw before, but we've kind of replaced a lot of the text and checkboxes with icons, which once you get the hang of it, it actually makes it much quicker to find the options you're looking at, because you're just looking for pictures rather than having to read the text. So you'll find a lot of the common controls down the bottom here that tend to be similar on various operation modes, and then above that is options that are more specific to this particular result. A lot of the animation settings are hidden in this little kind of pop-up option here, so you've still got the things like save animation button all hidden away there. So talking about noise brings us on to the other kind of new result we've got available in the NVH analysis now. So we've added an additional radiated sound power result. So when you're on an FE component, you'll see in your result options you've now got this airborne sound power result. And this is based on an ISO standard for converting vibration measurements into the radiated sound power from a casing that you've measured. And we've applied that to the vibration of our full FE component as a result of this analysis. It's a bit of a difficult analysis to do, so it takes a little bit longer than things like displacement, which we already have the results for, but it's still quite fast. And the only limitation of it at the moment is you need to have a full FE model, otherwise we don't know what the vibration is at every point over the FE casing. And you also need to have the displacement expansion vectors as well. They need to be present for the FE component, because otherwise we'd have to do quite a complicated analysis just to get this chart. But with that information, we can do it very quickly. The important consideration for this result is the kind of location. So it's taking kind of every face of the FE and averaging and calculating the total kind of average root mean squared normal velocity of every face. And we only want to really do that for the outside of the casing, because that's the kind of vibration that's going to get into the surroundings. So we have here some options for where this is shown, and I will show in a minute where these come from. So we have the all three faces group, and I've also got this outer option that I've created myself. So the other thing to note is, you notice there that with the new interface in MASTA 9, you also don't have to wait for this calculation to finish while you're changing options. So you can switch around and modify these options while it's processing. So you don't have to type in, change one number, wait for it to finish. You can just carry on changing options and it'll sort itself out. So that is the response, the sound power result for the casing, and we can look at that in kind of decibel scaling if you want, and change your reference value to whatever is sensible for your calculation. So these groups of faces are defined over in the imported FE mode. So you'll see in here we've got a new tab called Element Faces, and there's a number of new selection tools that can be used to create these groups. So we can switch here to surface selection, and this uses this kind of outline view that we have already in MASTA, and you can change what the tolerances are for these edges. So at the moment it's set to 30 degrees. You can reduce that and it will kind of pick up more of these more gradual edges, and then we can then click on these surfaces to select them, and then on our Element Faces tab we can then create a group from what we've got selected. And earlier I created this outer face group, which I can select, and you can see this includes all the outside surfaces of this casing. And when I return back to my MVH analysis, you'll now see that new group I've made now appears here as an option, so I can also look at that instead, and it will calculate the results for that. So it didn't need to even clear the analysis results, it just made that available immediately. So the final thing just to cover in our MVH changes is the export options. So previously we had a couple of options, so to export boundary conditions for your FE, either to another sort of FE solver package or as raw text. Those options now live here, so we've got these first two here, so boundary conditions as FE solver or plain text, and this writes out the displacements, all the forces as complex numbers to a text file. But this is a bit of a pain, because following you writing those out, we then have to run a harmonic response analysis in that FE solver to get the actual operating reflection shapes of the casing in order to then go to do an acoustic analysis. And as we've just shown, we've already got those operating reflection shapes in MASTA. We've already done those in our calculation. So instead, what we want to do is go directly from MASTA to that acoustic packages. And we've got a couple of options here for the output. So we've either got as an OP2 file. So this is a kind of Nastran results format, but it's well supported by most of the major acoustics packages. So certainly Actran and LMS Virtual Lab as well. They both support reading in these files. We also have a plain text option as well, which writes out the velocities of every node in your FE model, and this has to be used for programs such as ANSYS, which don't really support reading in any results formats. So that's what you have to use for that. And yeah, so if you want any help on that, we can certainly show you how to do that. Just to summarize that in a bit more detail. So previously in MASTA, we would do transmission error, going to our dynamic response, and then from there we'll be doing our harmonic response analysis and then acoustic analysis. So we've kind of moved more of this within MASTA to speed things up, and now we're going straight to our acoustics. And by using this export as well, we've done a bit of kind of validation work of our sound power calculation. So this was for a kind of electric vehicle transmission. We were comparing the sound power calculation we got from MASTA with doing a full acoustic analysis in this case in Actran. And you can kind of see on this graph that they're in pretty good agreement. There's some disagreement down the bottom here, which is due to the sort of radiation efficiency, which is a kind of input setting you can specify in MASTA, but it's something that it's not obvious what the value is until you've done the kind of detailed calculation. Certainly this mid-frequency range, you get very good agreement, and they drift apart a little bit once you get up to kind of very high frequencies as well. So to do that sound power calculation, there's a couple more inputs in MASTA as well. So you can now specify various air properties for your design, and these are kind of specified as standard kind of gas parameters. The defaults should be fine for most situations. They just sort of default to standard atmospheric pressure and for air. On the particular load case, using the temperature of the load case as well, we calculate the density of the air and the speed of sound, and then from this we get the characteristic specific acoustic impedance, which in this case is 413. So that number there is kind of crucial to calculating that sound power. The other input you can enter as well is the acoustic radiation efficiency. So by default we just use 1, but you can switch that to use a simple kind of parameterized curve, or specify a kind of lookup table for that as well. So if you've got a bit more knowledge about your particular transmission, you can modify that parameter, and that should improve the correlation between MASTA and your acoustic analysis. So that kind of covers the kind of NVH improvements in MASTA 9. So if you've got any more questions on that, then please submit them in the kind of webinar software. But I am now going to move on to just talking about the shaft meshing in MASTA. So in MASTA, you can create some shaft geometry. So you can specify your shaft profile, and we can define a number of features on that shaft. So if I just make a quick shaft together in our 2D view, so you can very quickly create things like fillets in your shaft, and you can also specify U-shaped grooves, for example. And these can now also, and if you've got a complex shape, then you usually want to replace that with an FE model. So when you create your FE in MASTA now, so previously we had the option of an externally reduced FE or a full FE mesh, but we now have this additional option of create shaft mesh. So if I pick that, I then need to select which shafts need to be replaced, which is just the one shaft I just made, and we then switch to our meshing options tab. And this has a number of options that I can kind of control the meshing process. So if I just take the defaults to start with, press mesh, it will mesh my shaft. So you can see initially it's kind of ignored my fillet, and that's because we've got kind of a minimum fillet radius to include. So I can just turn that down, mesh it again, and include that. So that's to kind of avoid ending up with very small elements where you've got kind of very small fillets in your design that aren't important. You can kind of set it to ignore those. It calculates a default element size for you, and this is based on the kind of minimum thickness that you find in your shaft, and also on the kind of diameter as well. So we want to make sure we've got a reasonable number of elements around the diameter and at least a couple of elements thickness as well. You can see it's put a much finer mesh in this groove here. We can control that as well. So if you want to get a more accurate mesh in this fillet, say, we can reduce these angles here. So reduce that down to 10 degrees, and that will mean it now has to put a lot more elements in this fillet in order to capture that shape correctly. So we've got two options for the type of elements you produce. So we have the tetrahedral mesh. That basically just takes the geometry, just puts it into the meshes that way. We also have a hexahedral mesh as well. So what this does is a bit quicker than the other one. So this meshes a kind of cross section of the shaft like this, and then does a sweep kind of cylindrically to create our elements that way. And depending on the kind of geometry you have, depends on which one of these is most appropriate. So certainly with hexahedral, I wouldn't use that on anything that doesn't have a kind of bore all the way through, because of doing this sweep, you then end up with some nasty wedge-shaped elements in the center here. But certainly for something like an annulus, where you've got quite a big, thin thing, a hexahedral mesh is quite good, and certainly it can give you much nicer kind of stress distribution in things like fillets, because it's much more of a regular mesh here on the surface. We can also use it for meshing gear blanks. So in this example, we've got one we imported previously, but I can also just mesh that within MASTA. So again, we select the create shaft mesh, and in this case, because of the particular geometry of this gear blank, we want to include these fillets here, and also under the rim here. It's actually in two parts of MASTA shaft, kept together with a kind of rigid connection. So all we have to do is select both of those to be replaced, and then again we just mesh our shaft. So once you've created your mesh, how you deal with your FE component is just the same as if you'd imported it. So we just set up the node connections exactly the same as you normally would. And one of the advantages is that because it's exactly matches the MASTA shaft geometry, everything should all be nicely lined up. So we just need to press the sort of default create nodes options, and it'll kind of get most things in the right place without us really putting in much work. And yeah, so that's something. Yeah, so it's a little feature it doesn't handle everything. So at the moment we can't mesh radial holes you defined in the shaft. It can only do things that are cylindrically symmetric, but it is quite handy for kind of small big gear blanks that don't have any holes in, or yeah, so you can use it for that. You can also do a lot of these operations in things like Parametric Study Tool or Runner as well. So you can automate changing shaft profiles, remeshing your FE, recondensing it, and getting results out that way as well. That's all features you can do as well. Okay, so yeah, so that's just covering the shaft meshing features. I mean, again, the results you get for this are, as a setup is, it's all just the same as you'd get for a standard imported FE component. So the one limitation at the moment, the other limitation at the moment is that you can't export the model, but that is something we are going to work on including in a future release as well. Okay, so moving on, another new feature in MASTA 9 is a more detailed spline connection. So I'm just going to switch this other model. It's a kind of slightly modified version of the model we were looking at previously. And in here we have set up this spline on the annulus to be, rather than being kind of bonded to our casing, we're now going to try and look at modeling the spline in a bit more detail. So when you have a kind of concept spline or a detailed spline component now in MASTA, under the stiffness type, there's a number of options. So previously, the default is the sort of simple stiffness, where you'd enter a radial, axial, torsional, and tilt stiffness values. We also had a specified matrix. So if you'd done a detailed kind of spline analysis in another program, you can import the matrix into MASTA. And we also had a kind of nonlinear spline capability where you could enter the stiffness versus deflection curve. But we've now got this fourth option of individual contacts, and this is for actually modeling contacts of the teeth. So when you select that option, we get a number of new options appearing now in our property grid. These should also be in the kind of default editor as well for the component. So we've got our kind of same inputs here as well. So we can enter what the stiffness is of the contact. We can put in a pressure angle. We can put in how big the teeth are on the external spline half. We can enter how many contacts we have in each direction, which is typically how many teeth you have. But I mean, this is quite a general kind of contact that can be used not just for kind of traditional involute splines, but also for things like a face spline, for example. We can enter the diameter of the contact, how much clearance we've got. You can also add a helix angle in there as well. And for the spacing of the teeth, by default they're equally spaced, but we can also switch to custom spacing. And if we do that, then it kind of hides the tooth size option, and we now can enter the dimensions of every tooth we have in our spline, which lets you do things that aren't equally spaced. So these options are available to any contact spline, and it will then use that in your system deflection analysis. The contact in this first release is quite simple. It's just using a simple kind of point contact in the direction kind of normal to the flanks. So each contact has either got this stiffness value or not. We don't include any frictional effects or kind of tilt stiffness yet, but that is something we're kind of working on for the future. But to make it even more powerful is usually a good idea to hook these up to FE as well. So you can use it with between two standard MASTA shafts, for example, but it will effectively be treating the kind of two sides as rigid. So it'll kind of be a slightly better clearance model, but won't get you much else. So in this example we've got a FE of our ring gear. So we've got quite a thin rim gear here, so we're thinking under load this is going to show quite a lot of deflections and out of round. So the contacts of the spline are actually going to be quite important for what the deformation is of this particular part. So we've set up nodes on either flank of every tooth around this external spline, and on the casing we have the mating half, which we can see in here. So we have also set up the other half of our teeth in there. So we've kind of created those connections in MASTA. We just imported the FE mesh in this case, and we have the option on the annular spline to create this flexible node ring. It will use the geometry you defined in the design mode to automatically set up these search regions to capture the nodes on the faces. So it's very quick to create all those nodes. It involves very little effort on the user part. These little yellow and red arrows there are to indicate the kind of normal direction on the flanks of the spline. That's just to make sure you've got it in the right place. So what you don't want is those arrows pointing inside of the teeth, because that means it would be the wrong way around. So when we now run that in system deflection, it will now take into account those contacts and give us a more realistic deformation of our ring gear in particular. So if we just have a look at that ring gear, we can now see this kind of hexagonal shape we get, because in this case we have 6 planets, so we get that kind of hexagonal shape. We can see the forces we're getting, so these larger arrows are from the gear mesh contacts, and these smaller ones are the loads on the individual spline teeth as well. So look at various things in that. So that covers the kind of flexible spline functionality. And that, yeah, like I said, there's more developed done this in the future. I mean, we'd like to spend a bit more time trying to improve the stiffness calculation for these contacts, and also looking at things like friction as well. So for bearings in MASTA 9, there's some changes to the mounting options that are available. So if I select one of my rolling bearings here, so previously there were a couple of options for whether you're kind of fixed mounting, or it could take load either to the left or the right, or axial load to the left or right, or if it was just sliding and so it could take no axial load. We've improved these options somewhat, so we made it a lot more detailed. So you've now got separate options for your mounting at the inner and the outer, and we've separated out the kind of options for the axial and the radial mounting. So at both the inner and the outer, we can specify whether the axial mounting has got both left, right, or none, and this affects these little pink squares which show whether it is constrained axially. So for example, this bearing here, we can see we have a shoulder on the shaft here, so probably at this inner it should really just be left. So then it's just constrained at this side and not at this side. And you can also specify a clearance separately for the left and right direction as well, if you wish, and that affects how much clearance you've got in this gap here. In terms of the radial mounting, we can now pick between an interference fit, a sliding, or a clearance fit. So the sliding is effectively not connected radially, so this would then be supported entirely by these kind of axial stops, and a clearance means you actually can now have a clearance value specified in here. So this radial mounting option is, you can specify it here in design mode, but if then on your load case you are using fitting and thermal effects, then it will ignore this setting and calculate whether you've got interference or a clearance or sliding based on your fitting and thermal effects, and it will automatically include that in your analysis. The kind of final new feature I was going to mention for MASTA 9 is CVT modeling. So on a CVT, you now have the option to use an improved model, and then this lets you separately connect your pulley to both sheaves of the pulley as well as the other pulley. So we now have a fixed and a moving sheave connection, and when we run our system deflection results, we can see that we now get some axial forces on those sheaves from that CVT as well. There's a number of options for controlling how this works. So we can specify what our clamping force is on the pulleys, and also how many nodes are used to model it. And just as we had previously, we can also specify a speed ratio on a load case for the CVT, and it will adjust the diameter of those pulleys automatically based on that ratio. So as we switch the ratio, it will adjust these forces automatically. Okay, so that kind of covers a lot of the new features in MASTA 9 that we wanted to cover today. Yeah, if you've got any questions now or after the webinar, then yeah, please let us know about those as well. And if not, I'm now just going to move on to talking about a few of the future developments that we have coming up in MASTA over the next year as well. And these are just intended to be a few of the kind of highlights. They're not the only things we're working on. We can't discuss everything that we're working on, but these are kind of some of the key areas that we think people will be interested to know about. So the first of these is scripting functionality. This is something quite a few customers have asked for, and a lot of other customers, as they learn more about it, are actually quite interested in this as well. So we're actually opening up a lot of the kind of underlying MASTA code so that our users do things directly. So we're introducing a MASTA API it's going to be using .NET code, and this is going to have several thousand classes. It's kind of wrapping up the classes we use in MASTA ourselves when we're developing the code, and will allow you to write your own, initially just .NET code, so using C# or Visual Basic, for example, and let you write your own code to manipulate those how you'd like. And so, for example, in the underlying MASTA code, we have classes for things such as bearings and gears. We have various classes for design mode, but also for results as well. And those are all going to be accessible to the users for doing things with. So, for example, you'll be able to kind of do simple things such as creating your own properties. So, some of our customers tell us they particularly like to use a different way to design their gears, for example. So this will let you define your own custom properties, and you can then use those in a parametric study tool, for example, or in a design space search when you're designing those gears. You'll be able to do things such as build up designs. So you may want to write your own scripts for building up your own kind of concept designs, for example, and obviously save and load these models. You'll be able to create analyses. So it's kind of like, in that kind of sense, it's a much more powerful version of our runner functionality. So you'll be able to kind of write your own scripts to do anything like that. You'll be able to send these scripts to other people. So yeah, you can either send them to other people in your team or make them available to other users on the internet if you like. And probably not in the first version, but then in the longer term, we also intend to let the users replace bits of the kind of MASTA functionality with their own code as well. For example, custom bearing or spline stiffness calculations or custom efficiency calculations. You'll be able to do these all using your own kind of bits of script. So another kind of area we're looking at in some detail is for kind of thin rim gears and improving our FE and LTCA functionality. So for example, such as the ring gear I showed previously, where you've got quite a thin rim and you've got quite large deformations in that gear, we think the tooth contact analysis can be improved in this particular case. And the kind of first step of this is to introduce the new spline functionality for getting more realistic deflections of that gear. But moving on from there, we also want to improve the coupling between the LTCA and our imported FE calculations as well. And hopefully you should see the results of this coming in the next year as well. So this will be actually using the detailed gear blank shape within the tooth contact analysis. So electric motors is quite a hot topic, particularly in automotive areas. For a while now, we've been able to import electric motor excitations from via Excel into MASTA and use these to run MBH simulations. So recently we've been talking to a lot of electromotor software providers and trying to improve our collaborations, and the first results of this are going to be able to import more formats directly into MASTA. So it'll avoid having to go via other kind of Excel programs, for example. So we'll just be able to go straight from electromotor software straight into MASTA and it reduces the kind of chances of error. And in the future, sort of moving on from there, we're sort of discussing about kind of closer coupling, so doing sort of co-simulation. So for example, taking into account the eccentricity of the rotor and how that affects the analysis, and probably initially statically, but then in the longer term in the time domain as well. Bearing developments as well, it's something we're working quite hard on. So we've been talking with various bearing suppliers about some future closer collaborations. Unfortunately, there's nothing we can really share about this yet due to confidentiality agreements, but please watch out for that. It should be quite exciting. And we're also looking into improving just our general detailed bearing analyses, so in particular things such as rib stresses and roller profiling. And finally, we are trying to do more advanced research as well, so we're funding a PhD project starting soon at Nottingham University to look at improving bearing life calculations. So okay, so that's about all we've got time for today. I hope you'll find it interesting, and yeah, please, if you have any questions that you come up with after this, then let us know. So yeah, like I said, this is the last webinar of this year, so we're going to be back again in the new year with another series of webinars. They should be around once every month, and certainly for the first few, these will be guided by topics that people have asked for at our recent user forums. But if there's anything else that you'd like to know more about, then please let us know, and if there's quite a few people interested in, then we'll kind of consider that for a future topic as well. Just had another question it's come up about the scripting functionality, about when that would be available. So this will be available early next year. So at the moment we're targeting the first quarter of next year for the scripting functionality. We'd certainly hope to be able to get a beta version to particularly interested customers so very early next year, and then looking at a formal release shortly after. Yeah, so thank you for everyone who's taken the time to listen to this webinar today, and yeah, let us know any more questions.